Hello everyone, this is Swati from Aeronautical Engineering. Currently, I'm here for the assignment for the Devops called Setting Up Kubernetes on Local Machines. Let's begin this. Introduction to Kubernetes on local machines. Setting up Kubernetes on a local machine is an excellent way to learn container obsessions and get hands-on hand experience with clusters. Kubernetes is a powerful tool for managing containerized application, and by running it local, developers can test development, simulate production environment, and troubleshoot configuration without needing a cloud and provider. This setup is especially helpful for learning purposes, prototyping, or even small scale development workflow. Various tools make this easier, like Minkubun, Kind, and Docker Desktop. Each has different strengths depending on your operating system and requirement. This guide walks you through everything needed to get started. Now, understanding and purpose of local Kubernetes. Running Kubernetes locally allows you to experiment safely without impacting live streams, setups. It's perfect for testing your YAM file because it's a file which contains a Kubernetes, all the data storage, and ham charts, and understanding how pod services and volume interact. Since local setups are lightweight and easily resist, they are ideally for repeated testing and trial or error learning. Unlike cloud-based clusters, the main cost money or require complex permissions, uh, for the local clusters is under full control. You can pause it or modify it, or rebuild it from scratch, which locally clusters aren't suitable for productions use. They are valuable as learning their development tools. As you can see, the Kubernetes looks like with the symbol. You can see the down. Next, pre-requesting before you begin. Before setting up Kubernetes, local ensures your system meets some basic requirements. First, you need a machine which at least 8 GB of RAM and modern multiple core processors. For a smooth experience, you all need visualization enable or your BIOS, since like tools like Minikube and Docker Desktop development on it. A good internet connection is necessary. Okay, for downloading and dependency and container images, familiarity with the command line helps a lot, especially while dealing with Kubernetes. Finally, ensures the Docker is installed and working properly on most Kubernetes local tools relay on container runtimes. Choosing the right tool for local Kubernetes. There are several tools to run Kubernetes, and choosing locally the right one depends on your needs. Minikubes is popular, supports multiple hyper versions and container runtimes. Kinds. Kubernetes in Docker is fast and designed for CI/CD, means CI, continuous integration and continuous development. It's a pipeline, basically we know this as a pipeline which commits, build, stage, deploy, and maintains. This is the pipeline of this Kubernetes. Okay, so this desktop includes a built-in Kubernetes option. Is a great for Mac and Windows users. Linux users often lean towards Minikubes or micro K8s developed by Canonical. If a goal is quick experimentations, Docker desktop is simplest. If you needed more customization or want to simulate clusters with multiple nodes, kind of Minikubes offer more flexibility. Installing Minikubes on your machine. Minikubes is one of the easiest way to set up Kubernetes cluster locals. To install Minikubes, find first ensures you have Docker or a driver. That virtual box install the download and Minikubes binary from the official website, or use a package manager. How homebrewer for Mac 0 OS, we have installed Minikubes or Cocolately for Windows. After installation, verify it use Minikubes version. Once installed, you can start your first cluster with Minikubes start. The command downloads the necessary images and boost up the local node Kubernetes cluster within a virtual machine or container. So moving to next one. Starting your first minikube cluster. To create a local Kubernetes cluster with minikubes, run minikubes start in your terminal. Minikubes widely automatically create a virtual machine in and install the Kubernetes components. It usually takes a few minutes, especially at first time. During the process, minikubes while set up Kubernetes kube proxy control panel are activate. This setup given you fully functional Kubernetes cluster on your local machine. Installing kubelts and connections to the cluster. Kubelts is the command line tool to interact with Kubernetes cluster. If you haven't installed it yet, now it is the time. You can download it from the Kubernetes website, or use package manager like Brew, Mac OS or Coco Windows. Once installed, confirm it works with Cobalt L version. Minikubes automatically configures your Kubernetes content, so you can run Kubernetes get nodes to verify the connection. This command should return the status of the nodes running in local clusters. If you have seen a single node mark ready, then everything set up correctly. Deploying your first application with Kubernetes running totally, it's time to deploy your first application. Can you create simple deployment with Cobalt L? Create deployment hollow nodes and with the images. Then this command start a pod using a basic echo service image. Then expose it is a server Kubernetes. This command returns the URL where the app is accessible. This exercise introduces key concepts like deployment, ports, services, and shows the Kubernetes routes traffic to your condensed applications. Moving to next one. Viewing resources and logs. After deploying an app, it's important to insert what's happening in your clusters. Use Cobalt L, get all the list, all sources, pod services, deployment, and more. So you can also run Cobalt describe pods with their names, detailed information about a specific pod, including event across errors, messages to view container logs. Use Cobalt log. These tools help you monitor and troubleshoot your deployment. If something fails, such as crash loops or image pull error, these commands provide insight. They essentially for diagnose issues you and understanding Kubernetes behavior in real life time. Updating deployments. So Kubernetes makes updating application seamless. Suppose you have to change the image version of your deployment, use Kubernetes L set image deployment with a code run. This command updates the container image to version 1.5. So Kubernetes automatically perform a rolling update, ensuring minimal downtime. You can monitor the rollout status with Cobalt rollout status deployment help node. If something goes wrong, revert to the previous version using Cobalt L rollout. Undo development hello node. This features makes local clusters powerful for experimenting with changes before applying them in production. Using the Kubernetes dashboards, Minikube supports a web-based dashboards that gives a visual overview of your cluster. To launch it, run Minikube's dashboards. This opens a new browser tab with a full GUI to monitor pods, services, configurations, and logs. It is a great learning tool for beginners and helps when you want to understand clusters activate visual rather than through the terminal. You can deploy application view logs, scale deployments, and even it YAML files directly in the dashboards. While not used much in production environment, it is an exactly resource of exploring Kubernetes concept locally. So moving to next one, exploring persist storage. Many applications requires persist storage beyond a continuous life cycle. In Kubernetes, this is handled using persist volume and persist volume claim. On a local setup like Minikubes, you can simulate this by defining storage classes that use host path or virtualized disk. Try creating a simple PVC YAM file and deploying it alongside your app to see the Kubernetes blind storages. Understanding storage is essential for database and stateful app. Local setup let you safely experiment the different volume types, reclaim uh, policies, and storage class behavior. Networking concept in Kubernetes. Understanding how networking works in Kubernetes is vital. Each pod gets its own IP address, and services allow access to these pods via stable endpoints. On Minikube, services of type load balancer are emulated using a tunnel or proxy. For testing, use a Minikube's tunnel to expose services on your local network. You can also use pods forwarding with Cobalt L, uh, pod forward to directly map pods for a pod of to your host machine. Exploring this networking features locally helps as gaps how Kubernetes manages internal and external traffic routing. Scaling application. Kubernetes makes scaling easy. To scale deployment up or down, use Cobalt L, scale deployment hello with the code. The command will create two additional pods distributing the local across. You can verify the change with Cobalt get pods. Kubernetes ensures new pods are scheduled and ready before terminating old one during scale down. This is a powerful feature for adapting your variable traffic. Even though local environments don't replicate real world traffic patterns, experimenting with scaling help to you to understand a deployment dynamic and resource management. So moving to next one. So, simulating failures. Local Kubernetes clusters are great for simulating failures and learning how recovery works. Try deleting and running pods with Kubernetes delete pods using the pod name. Kubernetes automatically recreates it based on the deployment configuration. You can also simulate node or container crash by pausing container or shutting down Minikubes temporarily. This scenarios helps you understanding self-healing capacity or capabilities and how control maintenance desired state. It's much safer to experiment local than in production, and these experiences prepare you to troubleshoot and recovery for real world failures efficiently. Using config maps and secrets. Kubernetes allows you to manage application configuration using config maps and secrets. This resources injects environmental variables. This and files command line argument in your container creates a config map using Cobalt L. Create configuration map config form literally with the keywords or with the code one. So this references is it is your pods are developed by AML secrets working similarly, but a base of 64 encoded for sensitive data like API keys. uh, try creating them local and mount them in your test container. Like practice improving security and flexibility when building application that depends on dynamic configuration or private credential. Managing multiple new spaces. New spaces in Kubernetes help to isolate environments and applications within a single cluster. You can create one using Cobalt L, create a new space, Devops, sorry, Dev, which is mean of development. Then deploy resources into using the N flag or by specific it in YAML files. Managing multiple namespace local. It is a great way to simulate multi-team setups or staging versus production environments. Use Cobalt L get all and development to view resources in the namespace. Let and this safely test scenarios like role-based control, resources quotes, or network policies without affecting your default namespace or other applications. So cleaning up your clusters. Over time, your local Kubernetes setup can get clustered. It's a good practice to clean up and unside resources. Use Cobalt L, delete deployment name Cobalt delete service with the code to remove the apps. For the complete reset, you can stop and delete the Minikube cluster using Minikube stop and Minikube delete. This cleaners out of all resources and reclaims dark space. Periodic cleanup keeps your environment and reduce resources consumptions on your local machines. It is also prevents configuration conflicts that many arises from state poles services or volumes. Troubleshooting common issues like for local Kubernetes setup may not work and expected. If Minikube won't start, click visualization settings in your BIOS or try switching drivers with Minikube art and with some of the code with the YALM file, restarting Minikube or cleaner to catch the and fix strange behavior. The key is to read logs carefully and follow error messages. Local setups may troubleshooting safe and educationally giving up confidential or large production environments. Wrapping up and next step, setting up Kubernetes on your local machines opens the door to the deep understanding of container instructions. Whether you are just beginning or refining advanced skills, local clusters are powerful tools for experimentations. You have learned how to install Minikube, deploy apps, scale services, manage stores, and stimulate productions like environment. For here you might explore HELM, CI/CD pipeline, custom controllers, and might be cloud provided like GKE or EKS. But always remember, your local clusters is playground and use it to test, break, learn, and grow your Kubernetes knowledge in controlled environment. So thanking you to all.